Bonjour, welcome to Wahsa Education Center's radio Zoom classes. This is MBF3C, grade 11 college math, and I am the teacher, Bronwyn Slate.
Unfortunately, this week you cannot participate live as our studio is under some construction and you can't call in. So this lesson is pre-recorded, though we are broadcasting on the radio at 91.9 FM and on the television at Bell Express View channel 972. Usually you will be able to join live through the Zoom link or call into the Wahsa studio to ask questions, but for this week, that is not a possibility. Still, how to know how to join the Zoom class with a link when it is available. So you should have a link that's provided from your DEC or from me, your teacher, to join the class. So you just click on that link and then a screen will pop up and you then choose to join with the computer audio. Then you will get a message that says the class will be recorded. So you click got it, as all of our classes are recorded. So I can upload them onto YouTube to share with other students and so you can refer to them again. I don't expect students to share their videos. So if you do join on Zoom to watch and ask questions, I encourage you not to share your video just so that your privacy is respected. Then on the bottom left hand side of your screen, you can click the video and microphone icons to turn them on or off. You also might have a little headset, which is what my image is, as I'm wearing headsets for the audio. And again, I encourage you to not have your video on. I don't have my video on. It just means that we don't have as much going on the screen and respects folks' privacies. And I ask you to keep yourself muted unless you are asking a question. Then to leave the class, you can click on End, which is at the bottom of the right-hand screen. If you get kicked out, you can rejoin the class. That's fine. If you leave, you can rejoin the class at a later time during the session. That's totally fine. You don't need to actually end if you need to step away from your computer, as you're muted and your video's off, so we won't actually know if you're at the screen or not. So no need to end if you need to step away and return. That is totally fine as well. All right, I just also want to go through how to get subtitles, if that is something that would be useful for you. So if you're in full screen mode for Zoom, you have this menu along the bottom of your screen, and you have an icon that says show captions, like a CC button. So you can just click on that and captions should then work. If you have captions selected and you prefer not to have captions selected, you can also click, if the captions are showing, then you click, it will say hide captions. So you can click that to hide them, whatever works best for you. Unfortunately, the captions most likely won't get everything that I'm saying exactly. I know I speak quickly, there's lots to jam in, and I might not enunciate as well as the caption settings would like. So I apologize for that if things aren't aligning as best as they could be. If you have your Zoom in a small screen, it looks slightly different. You have to click on these three dots, that the More menu, and then click on Captions. Then the screen will change. The little window, you can then click on Show Captions if you'd like to show captions, or it'll say Hide Captions if you would like to hide the captions. So again, this is going to be depending on what your screen looks like. It'll be a little bit different depending on what your needs are. I'd like to go over the difference between Radio Zoom and IL courses, as this is something that can be kind of confusing. So first, they are the same because the course material, the evaluations, and resources are all the same, whether you are registered in the Radio Zoom class or in the IL course, the independent learning course. Nothing is different in terms of the actual course material and process. Anyone is welcome to listen and participate in the Radio Zoom classes. You don't just have to be registered in the Radio Zoom course. You're still welcome to join us. And all of our lessons are recorded and posted onto YouTube shortly after airing. So this is something that everyone has access to, whether or not which version of the course you were registered in. So then how are they different? The Radio Zoom has a schedule of 4 terms per the year, and the classes run for 9 weeks. So during sessions, I explain the course concepts and show examples working through all 20 lessons, but those are spread out over those 9 weeks, and we start at the beginning and work through up to the whole 20 lessons. The IL courses, on the other hand, are open from the start of the year to the end of the school year, and students are welcome to start and finish those courses at any time, opposed to following along day by day like you can at the Radio Zoom class. So you can finish them any time between September 6th, 2022 and June 16th, 2023 for this year. If you're registered in the Radio Zoom class, the idea is that you are following along and handing material in at the same pace as we're going through week by week, and that you complete your full credit during that 9-week course. There is a potential to roll your course over if you don't finish it within those 9 weeks, but that's something to have a conversation with us directly to figure out what would work best for you. But that's really how they are different. Our classes are scheduled Monday through Thursday from 10 until 11 in the morning. And we are in our first week of our 9-week course. So to know what work to submit as we go through our course, the support questions, the ones with a little pencil icon, are not for marking. You decide which ones and how many to do. If you understand a concept, feel free to skip questions. You don't have to do them all just because they are there. If you need more practice, let me know and I'm happy to send you more practice. All of the answers are at the back of your book for the support questions, so please check your work to make sure you're on the right track. The key questions, the ones with the little key icon, are the ones to submit for marking. So please do all of these questions showing all of your work, your steps, and your thinking. This way I can understand what it is that you understand, and I can support you and help you if you are making errors. So then how do you submit your work for marking? Well, there's 3 methods. The first method is to scan and send your work electronically. You can scan your completed work through a device. If you have an Apple device, the Notes app has a scan function, and if you have an Android device, the Google Drive app has a scan function. These are free apps that generally come with these devices, and so are already on them and are fairly straightforward to use. If you need some support learning how to do that, I have videos on my YouTube channel that walk you through step by step how to use both these individual apps. They're under my playlist called the Tech Tutorials, and you can follow there along to learn how to do that. Once you have it scanned, you can then send it either by email to studentwork@nnec.on.ca and CC it to bronwyn.slate@nnec.on.ca, or you can send it through Facebook Messenger, where my name is B. Slate Wahsa. A quick moment of recognizing why I'm suggesting scanning versus just taking a picture. You can take a picture if that is what works best for you. If that's the only option that you have, that's fine. But if you scan using an app on your phone, it means that it's easier to create one file with all your pages so we don't lose anything. It's faster because it simplifies the image, and that makes it a smaller file, which is easier to send. This is why I encourage scanning, but again, if that doesn't work for you and you need to take pictures, if that's the best way for you to send work electronically, that is okay. If you want to learn how to scan with your smartphone, with your device, I'm happy also to walk you through that and to support you. If watching the videos isn't a great option for you, just let me know. I'm happy to support however I can. All right, so our second method is to drop off your work in Sioux Lookout. We have an outdoor mailbox at our location 74 Front Street. We are the bright red building next to the post office, and we have a small white mailbox next to our side entrance. So just put your work in there and we'll get it back to you as soon as possible. The third method is to hand your work into your DEC. Your DEC can either send your work through the Express or fax it to 807-737-1732 or toll-free fax to 1-800-463-7852. Students are also welcome to hand in their work by fax if that's something you have access to. We just ask that you give us a call or send me a message to let us know that you have sent a fax, as we've had some instances where things get faxed, but they don't get received. So we want to make sure that we get your work. If you'd like to connect with me through social media, both my Facebook and my YouTube channel are under the name B Slate Wahsa. You can friend me on Facebook and subscribe to my YouTube channel. And then every time I upload one of our radio Zoom classes videos, you will get a notification so that you know it is there. It's easy to find. As I've said, all of our radio Zoom classes are recorded and posted to YouTube shortly after broadcasting. So everything is there for you to find as accessible as possible. Also, on my channel, there are short videos that explain common errors and confusing concepts. So this is a really good place to go if you are struggling with something, or if you're feel like you're missing a piece that isn't necessarily a new concept, but is something that you've struggled with in the past. There might be something there on my YouTube channel that addresses this and just makes it a little bit easier to find that help opposed to doing a general online search. Math is a really visual subject, so I strongly encourage you to access the videos. Listening to me only on the radio is not going to give you the full experience, and things most likely will not make as much sense as if you access the videos and see what I am talking about on the screen. If you cannot join me live through radio Zoom, if you cannot access the YouTube videos, you don't have reliable internet, so those are not options, let me know and I'm happy to send you a copy of all of our recordings so that you still can get the full experience and set yourself up for the most success. If any questions or concerns, please reach out and contact me. My primary focus in my position is to support you, my students. You can send me an email at bronwyn.slate, that's spelled BRONWYN.SLATE at nnec.on.ca. Connect with me through Facebook, where my name is B Slate Wahsa. B Slate is all one word, second word Wahsa. Give me a call at the office at 807-737-1488 or toll free 1-800-667-3703. My office hours are Monday through Friday, 8 a.m. to 2 p.m. Though I teach from 9 until 11, so that's not a great time to try to get a hold of me.
All right, let's dive into our lesson. I won't usually spend that much time setting up, going over the beginning of our course. This is just, since it's our first day, I wanted to set it up pretty well. So lesson 1 in your IEL booklet in our course is transformation of quadratic functions. So our learning goals for our lesson are that at the end of this lesson, you will be able to recognize the important parts of a quadratic graph, specifically when it represents a real life situation. You will understand how A, H, and K change a quadratic graph, which is called a parabola. It's totally fine if that doesn't make any sense to you right now. Excuse me. Okay, you know you've met the learning goals because you can find the A, H, and K values in a quadratic equation. You know where they are, and you can explain the difference between a vertical reflection, a horizontal shift, and a vertical shift. Again, okay, that doesn't make any sense to you now, but at the end of the class, those are the things that need to make sense. And if they don't make sense by the end of the class, then we need to go back and look at things again. So the most common question I get as a math teacher is, when will I use this in real life? And I want to say that today and our course overall, we're strengthening our understanding of connections and seeing patterns. So you may not need to be able to find the A, H, and K values of a quadratic equation in your real life. Most likely you won't. It's true. But understanding connections and seeing patterns in your life, that's definitely something that's going to come up. So though it's not directly related to this mathematical concept, we're using this mathematical concept to strengthen this transferable skill that is something that you can use in various places in your life. But first, we're going to activate your brain with some mental math. You may remember Math Mad Minutes, where students all had to sit in their rows in their desks, and you've got a paper in front of you, and most likely a pencil, and there was a timer up on the board, or the teacher had a timer, and you had 1 minute to do as many math facts as you could, filling out of the paper. And they might have been multiplication facts, it might have been addition or subtraction, division, generally arithmetic facts, where you just had to do as many as you possibly could in a minute, and then you were graded on how good at math you were. Well, I don't believe that is a good strategy. This is not something that actually teaches students math skills and does not build confidence or comfort with math. So over our course, instead of focusing on that as a useful tool, we develop strategies where you think and you use logic that makes sense to you. You find friendly numbers that are friendly for you. There are multiple ways to figure out the answers to these problems, and that's all fine. And we're not having to do it fast. We don't have to have it memorized. We're just trying to understand and make connections. So we're going to do this, a mental math activity or question at the beginning of each of our lessons in order to strengthen our comfort and our confidence with our numbers. So our question today is 17 plus 4. And we're going to use a strategy of friendly numbers. And what I mean by friendly numbers are numbers that feel friendly to you. Each of us might have different numbers that are friendly, but there's probably a few that are fairly consistent in terms of friendly. So often things that end with a 5, so have 5 in the ones column, or 5 ones, or have 0 ones. And so with something like 10, 20, 30 ends with a 0. Those generally are friendly numbers that make our life a little bit easier to deal with. So this question, 17 plus 4, when I look at it, and that 7 and that 4 I need to add together, and they're not super friendly. I could count on my fingers, totally fine. Counting on your fingers is a great way to do it. It's a great strategy to use. It makes your brain light up. Brain science has shown us that makes connections using your fingers, counting on your fingers, highlights more activity. It makes your brain think really well and make connections. So it's great. So what I'm going to think about in order to make my friendly numbers is I'm going to look at this 17, and I really want that to be closer. I'm going to think if it was 20, then that would be friendlier for me. So I'm going to break my 4 into a 3 and a 1, because 3 plus 1 is 4, sorry. And then if I do 17 plus 3, 17 plus 3 is 20. I know that 7 plus 3 gives me 10, so 17 plus 3 is going to give me 20. And now I can just add that 1, and I get 21. So that was pretty easy for me by breaking my numbers up into friendly amounts. Things that I was comfortable and confident with made it pretty easy to add that 17 plus 4. This is a simple example where we could have just counted our fingers. It's not very much, but it's something that we're going to use again later on, this idea of making numbers that are friendly for us. All right, so then before we dive into our new concepts, we just need to sort of think about what learning we've done before. And I want us to remember linear graphs. This is something that would have shown up in your grade 9 and your grade 10 courses a little bit. We're not going to spend very much time really in this course on linear graphs, but we just want to remember them. So linear graphs are this idea that if we're moving at a constant, a consistent, the same rate, then we get a straight line in our, if we were to graph it. So here we have a little person on a roller coaster, and we see that if their roller coaster drops 225 feet over a short distance of 75 feet, this is a very steep roller coaster. And this person, you can see, is going really, really fast. However, if we have a second roller coaster that drops at a rate of 300 feet, a distance of 300 feet over 300 feet, that roller coaster is not so steep. The steepness of our line has decreased. And then thirdly, if we have a roller coaster that drops only 100 feet over 250 feet, then this roller coaster is much more shallower. We can see that this line is much less steep. So in linear graphs, we talked a lot about this idea of slope, where we were comparing the rise, how much we go up or down, and the run, how much we go over, and how that affects the steepness of our line. So we would have put this into a formula, which is y equals mx plus b, where m, our number here, is the slope or the rate of the change. So how fast our line, how steep our line is, how fast our roller coaster is. And b is our starting point, which is our y-intercept, which when we graph it is this point here, here on where it crosses our y-axis. So this should all be something that is kind of familiar, and how we can have an equation like y equals mx plus b, and how that changes our line. That it, as we change, here I will show you, this link will work. So we can see here, we have a rise of 5, a run of 8, and a starting point of 3. So if I change this, my line can get less steep or more steep, and our numbers change, our m changes. And if I move this dot here, our starting point changes, which potentially could change our steepness of our line, not necessarily, depending on the situation. And so as we move that information around, our equation changes. And so that's what we kind of want to think about today, is that when we're moving our parabolas around, is this idea that as we move things around, as our situation changes, our equation and our picture changes together. I will put a link into our show notes of the YouTube so that you can go and check that out if you want to play around with that. Okay, so that's what we just sort of need to remember, that idea of how we manipulated lines in the past. And now we need to dive into our new concepts. So parabolas are all around us. When we talk about quadratic equations, parabolas are the picture that we see. So it's this line that arches. So here on this basketball player is shooting this basketball, and it's following the pathway of a parabola. So it goes up, it goes to a highest point, and then it comes down at the same rate. So it like goes up and it slows down, and then it goes faster and faster and faster, and it has this symmetrical shape. This shows up in various other places. Here we have a water fountain. You can see this arching shape, and even here at a drinking water fountain, this going up and then coming down. But also, not just with movement, but in our structures. So swings have a parabola shape, this U shape or V shape kind of. Archways have a parabola shape. This bridge has the support systems are in place. They have, this is the parabola shape here. We go up and then come down and then go up and then come down. And even a banana has a parabola shape, just to sort of see that this parabolas are everywhere around us. So back to when we were looking at linear graphs, we talked about how y equals mx plus b is sort of it's called the parent function. It's sort of the general idea. So for a parabola, the parent function is y equals x squared. And that's sort of our base where we're starting from, and everything all of our other parabolas, all of our other quadratics come based off of this simple idea of y equals x squared. So what this actually means, if we can, using a table of values so that we can see what this actually means when we're talking about y equals x squared. If we pick an x value and then we square it, we can figure out a corresponding y value. We can find a relationship between these two numbers. So if we pick 0 and we do, so x is equal to 0, 0 squared is 0 times 0, and so that is also 0. If we pick 1, 1 squared is equal to 1. If our x is equal to 2, then 2 squared is equal to 2 times 2, so that equals 4, so our y equals 4. 3, so our x value is 3, our y value is 3 squared, which is equal to 9. And 4 is our x value, then 4 squared is equal to 16. So with the table of values, we can pick any values of x, and we can figure out the relating y. We can also use negative numbers. So if I pick x equals -1, then -1 squared is equal to 1. -1 times -1 is equal to +1. So it's important to know our multiplication of our positives and negatives for this course, something that really comes up a lot. -2 is -2 squared is +4. -3 is our x, our y is equal to -3 squared, which is 9. And -4, our y is equal to -4 squared, which is 16. So you'll see a pattern in our numbers is that it's symmetrical around 0. So both 1 and -1 is +1. 2 and -2 are both +4. 3 and -3 are both +9. 4 and -4 is both +16. And that pattern is going to continue. And when we plot those points, we plot them on our graph, and then draw a line through them, we can see that this U parabola shape is developed by that pattern of squaring our x values. So that is our parent function. This shape that we're seeing here, where it's our U shape is symmetrical around the y-axis. So it's the same on both sides of the y-axis. It's like a mirror down the middle. It's all above the x-axis. It's all opening up. And it goes right through 0, 0. The vertex, the very tip of our parabola, sits at 0, 0, right at our origin. So the general form of this of this shape, is y equals a times x minus h. And this we then say quantity squared. So x minus h inside this brackets is all squared plus k. Now that really doesn't make a lot of sense because this is just our general form. So then we can change these a, h, and k values and get various different parabolas. So for our parent function, our a is equal to 1, our h is equal to 0, and our k is equal to 0. So we put that into our general formula. A we replace with 1, h we replace with 0, and k we replace with 0. Well, x take away 0 is just x. X squared we can't do anything with because x we don't know what it is. It's one of our variables. 1 times that is just going to be x squared. And then we add 0, just means that it's going to be x squared. So that's how we get y equals x squared as our parent function, because we're not changing any of these values. These are sort of our baseline values, our invisible numbers. We don't show up here. We don't put a 1 in front of the x squared. If there's no number there, we assume that it's 1, because 1 times this number just gives us that number. So let's understand a little bit more what we are talking about. Sorry about my cough. So if we're trying to understand y equals x squared, let's look at a concrete example. So x represents the side length of a square. That's what, when we say x squared, that's why we say x squared, is that we are saying a side length of a square. So we have a square, and the length of each side is x. So then y represents the area of that square. So we're comparing the side length of a square to the area of that square, which is equal to, if you remember, the area of a square is equal to your side times your side. So x times x is x squared. So that's what this relationship is, the same idea. This is a concrete way of looking at this relationship, of comparing the side length to the area of a square. So let's look at that a little bit more. Remember that x is our side length and y is our area. So if we have x a side length of 0, then our area is 0. I have this sort of phantom square here because there's no actual square there, because 0 times 0 is 0. So if we have a side length of 0, we don't have any area. That makes sense. So in our table of values, we have 0 and 0. If we have a side length of 1, well, our square having a side length of 1 and 1 means that our area is a total of 1 unit. So y equals 1 as well. If we have a side length of 2, x equals 2, then our area now is 2 times 2. So we can see that we now have 4 as our total area. If we have a side length of 3, we can see that our area of our square is 3 times 3. And so that means that we have a total area of 9. And if we have a side length of 4, we can see that 4 times 4 is equal to a total area of 16. Now, the pattern continues with if we were to have negative values for x, if we had a side length of a negative value, but that's not something that really makes sense to us, so we're not going to go there. We're just going to trust that if we extend this with this pattern, is the same idea. With when we're looking at this concrete example, we're only going to be looking at positive values. So here on our graph, we can see if we plot these, our x and our y's, we can say 0, 0 is a point, 1, 1 is a point, 2, 4 is a point, 3, 9 is a point, and 4, 16 is a point. And if we connect those on our curve, we can see we have this half of our parabola shape. That would be reflected the same if we had negative values, but again, remember, we're only thinking about positive values for this concrete example. So that is how our parabola, the idea of comparing our side length to our area, is the basis of this relationship shape. So with math, one of the basic principles of math is looking at something and then asking, but what if we do this? What if we do that? And that's how many things get developed in mathematics, is that somebody thinks about something and figures something out, and then they or other people ask, but what if we do this? What if we do that? And so we are going to look and say, but what if we manipulate the situation and change something? What happens? So this, we're going to examine the K and we're going to see if we manipulate the k, what happens. Now this is on page 5 of your IL booklet. Your IL booklet starts with A and then does H and then does K, and to me it makes more sense to look at K and understand that first, and then understand H, and then understand A. So I'm going backwards compared to what your booklet does in this lesson. If you're watching this whole lesson before you do any of it, it's all good. Doesn't matter. You don't have to do in that order. But just to know that we're looking at K first, and this is on page 5 of your IL booklet. So if we're asking what if, we're saying, well, what if we add a number after we square the sides? How does that change the pattern? So we're doing the same idea, but we're going to still square our x is still our side length, y is still our area, but we're going to add a unit to it, and we're just going to use the example of 1. We didn't have to use the example of 1, but just keep our numbers simple. I'm using the example of 1. So we are going to, our h is still 0, our a is still 1. We're not changing those. We're just changing our k, because we're just going to look at our k, and we're going to look at this example if our k was 1. So if our side length is 0, and that means our area is for that is still 0, but then we're adding 1 unit afterwards. That's what this means, is that we put in a side length of 0, we square it, our area is 0, but then we're adding 1 more. So here, when x equals 0, y equals 1, because we added this 1 extra unit. Now, if we have a side length is equal to 1, now we have an area of equal to 1, plus we're still adding that extra 1. So now we have a total of 2. So when x equals 1, y equals 2. If x is equal to 2, our side length is equal to 2. So our area, our original area, is 2 times 2, 2 squared, which is 4, plus 1, because we have that extra piece that we are adding in. So when x is equal to 2, y is equal to 5, because 4 plus 1 equals 5. And we continue this idea with, if x is equal to 3, our side length is 3. That means our area is 9. 3 squared is 9. Plus 1 means we have a total area of 10. So when x equals 3, y equals 10. When x equals 4, we have a total area of 16. 4 squared is 16. Plus this other 1 that we still have. So when x equals 4, y equals 17. So our pattern has shifted. Our x values are still the same. We pick the same ones, but our other values have changed. They've shifted, they've moved, they've increased by 1 because we added 1 each time. So if we were to graph that, we can see that this y equals x squared is still our parent function, this black one, but this red function, y equals x squared plus 2, was our new function that we were investigating, and we can see that each of our points have now shifted up 1. So our whole parabola has shifted up because we added 1 to it. Okay, so what if we subtract after we square the sides? How does that change the pattern? So now we're going to do x squared minus 1. How does that make it different? So if x is equal to 0, we have a 0 side length. So our original area is 0 squared, so that's 0. But then we're subtracting 1, so we're taking 1 away. So that means if we have 0 take away 1 is negative 1. So when x is equal to 0, y is equal to negative 1. When x is equal to 1, our side length is 1. So our area is 1, but we're subtracting 1. So 1 take away 1 is 0. So now we have x equals 1 and y equals 0. When x equals 2, when our side length is 2, then we see that our square, 2 times 2 is 4. 2 squared is 4. Minus 1, so we're subtracting that 1 off. So that means that we have 4 take away 1, which is 3. So when x equals to 2, y equals 3. When x equals 3, we have 3 squared, which is 9, but then we're taking that 1 away. So we take 1 away, and so we're left with 8. So when x equals 3, y equals 8. And then when x equals 4, our side length is 4, our area of our square is 16, 4 squared is 16, take away the 1, so we're left with 15. So when x equals 4, y equals 15. So again, our pattern, our x's are the same, we pick the same values, but our y values have all decreased by 1 because we subtracted 1. So if we were to graph that, our black one is our parent function, y equals x squared, but we can see each of our points have now shifted down for this green line, y equals x squared minus 1. All of our points have shifted, and we still have that parabola shape, but it's all been shifted down. So we could go through and we could do all of the numbers in the world, but that would be a lot. So instead, we're going to look at this GeoBra little application where we can see that it here, if we change our k value, remember a is still equal to 1, h is still equal to 0. If we change our k value, then this changes our whole function. So if we increase our k value, we make it a bigger number. We're going to go up to 3.5. So k is now 3.5. Our equation is y equals x squared plus 3.5. And we can see our whole parabola has shifted up. Every point has moved up 3.5. And it looks a little bit funny because here it looks like they're getting closer, but remember we're comparing it down along these vertical lines. So this point here has moved all the way up here. It shifted all the way up. So our whole parabola shifts up by 3.5. So k equals 3.5. That means our parabola moves up 3.5. If our k value is negative, if I go down here and I go all the way down to -5, then all of our values, our parabola, every single value has shifted down 3.5. So this value here has moved, sorry, not 3.5, has shifted down 5 because our k value is -5. So here, instead of being at 4, it's shifted all the way down, and now it's at -1. And so every single one of our parabola points has been moved down negative. It's been moved down 5. So our formula is y equals x squared minus 5. So our k value is -5, and our parabola moves down 5 units. So k value is called a vertical shift. That is what the basis, that's what the transformation is called. And if we have a positive k value, we shift our whole parabola up by that value. And if we have a negative k value, then we shift our whole parabola down by that value. And that's how it works. Shifting it up or down based on how much the k value is. So let's do some practice problems. So we're going to state how the parabola shifts and what the k value is for each of these equations. So A is y equals 4 times x minus 3 quantity squared plus 6. Now we've got a lot of stuff going on and we didn't look at this. And so we have to remember that our k value is our number that is at the end. Doesn't matter if we have other numbers in there. It's our number that was being added or subtracted on at the end. So for this question, k equals +6. So that means that we are we moving up or down? If it's positive, that means that we're shifting up 6 units. All right, part B, y equals -x plus 25 all squared plus 100. Again, it doesn't matter what these other numbers are going on. We're just looking at this at the end. It doesn't have to be at the end. It usually is, but it's what we're adding outside of the brackets. So k is equal to plus 100. Okay, well, if it's positive, then we're shifting up. And the number 100 is how many units we do it. We're shifting up 100 units. C equals x minus, y, for number C, for letter C, y equals x minus 17 squared minus 42. Again, we're looking at this value outside of the brackets is our k value. So k equals -42. So it's negative this time. So that means that we are shifting down. And it's 42 units. And letter D, y equals -1 times x plus 5 quantity squared minus 50. Our k value is this minus 50. So it is negative. So again, we are shifting down, this time by 50 units. And that's how we can identify our k value in a parabola, is that we're always looking at this number that is outside of the brackets. And we're looking at the sign too. The sign tells us if it's up or down. All right, so practice problem 2, graph the following functions. So we're going to look at y equals x squared plus 5. Well, remember, for this, we think about our parent function, which you'll get used to knowing. Mine is not perfect. It's really hard to draw these perfectly, particularly on a computer screen. But it's roughly this, though it's totally, sorry. I'm just going to draw this new one because I'm having a really hard time getting it properly. You can just sketch these and it's okay if it's not perfect. So for y equals x squared plus 5, we know that we're shifting up. Our k value is equal to plus 5. So we're shifting up 5 units. So instead of being at 0, 0, we're going to be at 0, 5. Instead of being at 1, 1, we're going to be at 1, 6. Instead of being at 2, 4, we're going to shift up to 9. Instead of being at 4, 16, we're going to shift that 4 up to 21. And the same thing on the reverse. Once you do the positives, you can kind of just go with and look at the negatives and make it symmetrical. Now, this should be a really smooth curve. As you can see, it is not, because it is hard to draw. When you're doing it by hand, you can turn your paper around and you can use the curve of your hand, and that can work really well. But again, it's about the idea. It's okay that it's not perfect. It's key to label your graph so that you know, and that I know, what it is that we're talking about. So y equals x squared plus 5 has shifted up 5. Y equals x squared minus 7, because it's minus 7, k is equal to -7. So we're shifting down 7 units. So the same thing, 0, 0 is now going to be 0, 7. 1, 1, we're going to shift down to be 1, -6. 2, 4 is going to be 2, -3. 3, 9 is going to be 3, 2. 4, 16 is going to be 4, 9. So these numbers, I know in my head. You can use the a table of values, or you can also draw your parent function, which is what I was hoping to do, but because I'm bad at drawing on here, I didn't. And then you can move each point down by 7 units for this particular question. And there we go. Now we've sketched that graph. All right, so we have run out of time and we have lots left to do. So we're going to finish the rest of our lesson in our next class.
If you have any questions or concerns about this lesson, please reach out and contact me. Give me a call at the office at 807-737-1488 or toll free 1-800-667-3703. Send me an email to bronwyn.slate, that's spelled BRONWYN.SLATE @nnec.on.ca. Connect with me through Facebook at Wahsa. And remember, my YouTube channel is also called Wahsa. All of our course material and supports are found under a playlist called MBF3C. So you can find all of our recorded lessons there to support you. My office hours are Monday through Friday, 8 a.m. to 2 p.m. And I'm willing to negotiate a time to meet outside of those hours if need be to give you the support that you need. Thank you so much for joining me today. Mogich.